Place about 20 milliliters of water into a 50 milliliter beaker. Heat the water on a hot plate and cover with a watch glass until almost boiling. Place the tea bag into the hot water so it lies flat on the bottom of the beaker. Continue heating for 15 minutes. Gently push the tea bag down to ensure constant contact with the water. During the heating process, replace evaporated water with a pasteur pipette. After 15 minutes, remove the tea from the heat. Using a pasteur pipette, transfer the concentrated tea solution to 2 centrifuge tubes fitted with screw caps. To squeeze additional liquid out of the bag, hold the tea bag against the inside of the beaker and roll it with a test tube. Be careful not to rupture the bag. Add this liquid to the centrifuge tubes. Add 2 milliliters of hot water to the tea bag, then repeat the squeezing process. Ensure the tea levels are even for centrifuging. Measure out 500 milligrams of sodium carbonate. Add the sodium carbonate to the hot liquid in each centrifuge tube. Cap the tubes, then shake the mixture until the sodium carbonate dissolves. Once the tea has cooled to room temperature, use a calibrated pasteur pipette to dispense 3 milliliters of methylene chloride to each centrifuge tube to extract the caffeine. Once again, cap the centrifuge tubes. Gently shake the mixture for several seconds. Vent the tubes to release the pressure. Methylene chloride is toxic. Take care that none escapes towards you. Shake the mixture for an additional 30 seconds with occasional venting. To separate the layers, centrifuge for several minutes. If an emulsion still remains, centrifuge further. Using a pasteur pipette, transfer the lower organic fraction of each tube to an Erlenmeyer flask. Leave some of the organic layer behind to minimize transferal of the brown aqueous fraction. To remove more caffeine, add 3 milliliters of methylene chloride, shake, centrifuge, and pipette just as before. After the second round of extraction, decant the organic solution into a second Erlenmeyer flask. This further purifies the organic solution, as aqueous impurities will cling to the inside walls of the first glassware. Add a small amount of anhydrous sodium sulfate to dry the organic fraction. Enough sodium sulfate has been added when clumps no longer form when stirred with a spatula. Allow the mixture to stand for 10 to 15 minutes. Leaving the drying agent behind, pipette the organic solution to a dry, round-bottomed flask suitable for rotary evaporation. This is a Rotovap. It will be used to isolate crude caffeine. To operate it, first, snugly attach the round-bottomed flask to the glass joint. Second, attach the plastic clip to the joint. There is a small and a large side of the clip. The large side attaches closest to the flask. Third, by pinching and sliding the lever, lower the flask into the water bath. Fourth, turn on the rotor by rotating the dial labeled RPM. Fifth, close the inlet valve. And finally, sixth, located on the back of the Rotovap, flip the switch and turn on the vacuum pump. To remove the round-bottomed flask containing the crude caffeine, repeat the previous 6 steps in reverse. Dissolve the crude caffeine in about 1 milliliter of methylene chloride to create a concentrated solution. This will be transferred to a pre-weighed conical vial for sublimation. Weigh the vial which will be used for sublimation. Record the mass. Transfer the concentrated crude caffeine solution to the pre-weighed conical vial. If needed, rinse the round-bottomed flask with more methylene chloride. Place the conical vial into a small beaker so it will stand in an upright position. Leave the vial open so the methylene chloride can evaporate. The weight of the crude caffeine will be determined by the change in mass. Leave the vial in a fume hood until the methylene chloride has evaporated.